Hello everyone, welcome back to our course. Next, we are going to introduce Hive, which is a distributed data warehouse. Just as the title suggests, Hive is a distributed data warehouse running on Hadoop ecosystem. And it could be used to deal with a large volume of data with terabyte or even petabyte level. And below, we list several features of it. Firstly, it supports flexible extract, transform, and load, or ETL in short. ETL plays an important role for data analysis and even data mining. If we need the data to be analyzed on Hadoop ecosystem, we need a unified data format, and we need to extract all the data from their sources and load them into Hadoop clusters, right? And between the extraction and the load processes, we can make some transformation and some data cleansing as well to transform the data into the target data format. But the transformation is not always needed, namely, it is optional. Secondly, it has multiple computing engines, including Tez, MapReduce, and Spark. Previously, Hive used MapReduce as the default computing engine, but in the latest version, now the default computing engine of Hive is Tez. And to some extent, Tez is just an updated MapReduce. This means that Hive will compile the statements into MapReduce or Tez tasks, and then executing the tasks to do data analysis or data queries. Thirdly, it supports direct access to HDFS and HBase. In fact, Hive never stores anything, but all the data need to be read from other storage systems like HDFS or HBase. This is different from the conventional data warehouses like Teradata or Greenplum, right? But this is essential for Hive because Hive implements a separated architecture of storage and computation, which improves the computing efficiency and meanwhile simplifies the optimization and maintenance processes. Finally, Hive is easy to use and easy to program. This is because Hive helps us to do the data analysis with SQL-like statements, rather than writing codes with Java or Scala. As is known to all, Java programming is relatively a difficult job for many people, especially for the beginners, right? For a beginner, perhaps he will need 4 to 6 weeks to master Java programming skills and implement it in big data analysis. But for SQL statements, a beginner might only need 4 to 6 days, and then he can just do the big data analysis fluently. In short, it doesn't add much to the cost of learning and is very easy to deal with massive data analysis. Just as shown in the figure below, Hive just helps to translate SQL queries into MapReduce jobs and runs the jobs on Hadoop. In this page, we can show you some of the advantages of Hive. Firstly, high reliability and high fault tolerance. Because the Hive server depends on HDFS clusters, and HDFS has a high reliability and high fault tolerance. Apart from it, Hive can be deployed with double meta stores. Therefore, the metadata is also kept with high reliability. And moreover, when we query massive data and encounter some problems, the time cost may exceed the time threshold. Then the failed task will retry many times until the maximum number of retries is reached. Secondly, Hive uses a SQL-like language called HQL. and is equipped with many built-in functions as well, so it is rather easy to use. On top of that, the users are allowed to define many user-defined storage formats or user-defined functions, which improves the flexibility and customization capability as well. Finally, it supports multiple interfaces like Beeline, JDBC, Thrift, ODBC, and Beeline is just the command line interface of Hive. And JDBC, Thrift, and ODBC helps the user to connect Hive with other databases for data query. And thanks to all the highlights and features introduced before, Hive has many application scenarios. Firstly, data mining. We say Hive is a data warehouse, and a data warehouse is helpful in data mining processes because it provides various pre-processing services. If we regard the original data as a mountain, and data mining is to dig the vital information out, then a data warehouse is just a cave to the gold. Without data warehouses, we can still dig the gold out by our bare hands, but data warehouse provides us with a platform as well as some pre-processed results for convenience. This is just one of the advantages of data warehouses. Secondly, non-real-time data analysis. Please pay attention to this keyword, non-real-time. So we emphasized again that Hive is not suitable for real-time analysis like some OLTP applications because it is relatively slow. And typically, we can use Hive in log analysis or text analysis. Thirdly, data summarization. Again, this is another typical offline computing application, and we can use Hive to do web page click analysis in a daily or even monthly manner, or use Hive in traffic statistical analysis, and so on. Finally, as a typical data warehouse tool for big data, naturally, Hive is suitable to do some ETL jobs for data analysis or data mining. Okay, maybe you are wondering, in real industry, we have other data warehouses like Teradata or Greenplum. So what is the difference between Hive and those conventional data warehouses? Here, we have drawn comparison between Hive and conventional data warehouses in many aspects in this table. The first aspect is the storage capability. The storage capacity of Hive is dependent on HDFS, which can support thousands of servers and manage data at petabyte level in practice. While the traditional data warehouses are based on the relational data clusters, which support hundreds of servers and manage data at terabyte level at most in real industry. And moreover, with the increasing of data volume, the computing speed decreases sharply for the conventional data warehouses. But for Hive, thanks to its distributed feature, it gets a linear scalability very easily. Secondly, execution engine. We have mentioned that the underlying computing of Hive can be operated by MapReduce, Tez, or Spark. While the execution engine of traditional data warehouses vary from different database companies, more optimization measures can be taken to improve the efficiency to query data. Thirdly, the usage. Hive uses the HQL statements, while traditional data warehouses uses the normal SQL statements. HQL is the abbreviation of Hive SQL or Hive QL, which is very much like the traditional SQL statements. So we say that the usage method of Hive and traditional data warehouses are similar to each other. Fourthly, flexibility. For Hive, the metadata storage is independent of data storage. Or namely, Hive achieved metadata and user data decoupling. Thanks to this property, we can define managed tables as well as external tables for different purposes. And that is why we say Hive is more flexible than traditional data warehouses. Fifthly, analysis speed. For this aspect, it depends on the data volume. To be more specific, Hive is slower than the traditional data warehouses when the data volume is only in megabyte level. But when the data volume reaches terabyte or even petabyte level, the traditional data warehouses meet bottlenecks. But Hive gets a linear scalability very easily, so in this case, Hive becomes faster than the traditional data warehouses. Therefore, for the application scenarios with a huge amount of data, Hive could be even more efficient than Teradata or Greenplum in some cases. This is amazing, right? But still, this is not contradict with the fact that Hive is not suitable for real-time computing, because Hive still requires several hours in order to deal with a large amount of data. Next, index. However, we say that the index is not a strength for Hive, because the index of Hive is in low efficiency and rarely used, while the index of traditional data warehouses is highly efficient and widely used. Next, easy of use. But again, it depends. For the beginners, they may prefer to use the traditional data warehouses because a set of mature report solutions are integrated to facilitate data analysis in traditional data warehouses. So we do not need to do many extra works or acquire extra knowledge. But for those who prefer to write some functions or applications on their own, then Hive provides more flexibility to do so. We can define many user-defined functions via Java and then implement these functions to do complicated jobs. Next, reliability. For this aspect, the reliability of Hive actually depends on HDFS. And HDFS supports high reliability and high fault tolerance by software. While the traditional data warehouses solve these problems by hardware RAID, which is also a redundant mechanism. But after all, the reliability of traditional data warehouses is lower than Hive. As for environment dependency, Hive uses the scale-out strategy and is built up on a distributed cluster, so there is no strict demanding on the performance of each node. But for traditional data warehouses, because they require high-performance servers with more powerful CPU, RAM, and greater network bandwidth, etc., we usually use the special high-performance commercial servers and expand the cluster vertically for traditional data warehouses. Finally, since Hive is an open source product, so it is free. But for traditional data warehouses, they are quite expensive in most cases. For example, the starting price for a Teradata database is about $100,000, and you have to pay expensive maintenance charge every year as well. Okay, so from all of these aspects mentioned above, I assume that you should have a more comprehensive understanding of the strengths and weaknesses of Hive compared with traditional data warehouses. But it is not absolutely whether Hive is better than traditional data warehouses or not, because it still depends on different occasions and different purposes. After all, Teradata is still one of the most widely accepted data warehouse tools for many enterprises, although it is still so expensive, right? Okay, then let's have a look at the architecture of Hive. Here you can find the gray area called driver, which is the brain of Hive. All the tasks are just processed in this driver. But from the graph, you might have found out that the driver could be further divided into three parts: compiler, optimizer, executor. Indeed, we have mentioned this before. Since the user writes commands via Hive SQL statements, Hive needs to compile the HQL statements into tests or MapReduce or Spark jobs. And that is exactly the responsibility of compiler. But maybe the jobs are not in a good order, or maybe they have many unnecessary computations. So Hive needs the optimizer to optimize the workflow. And after optimizing, Hive uses the executor to execute all the jobs by the relevant engines. And on the right-hand side, you can see the met store, which stores metadata of tables like table name, table size, and so on. And on the top, there are several interfaces as mentioned before. So as you can find, gDBC and ODBC needs to go through the Thrift protocol for serialization. But if you want to use the command line interface, just use beeline and it leads you directly to the driver. Finally, this chapter is going to end here by introducing the data storage model of Hive. Just like many relational databases, there are concepts such as databases and tables in Hive as well. But the underlying storage takes many formats, such as bucket and partition. Simply speaking, both partition and bucket are used to divide a Hive table into several small segments, and thus we can improve the efficiency. But there is a basic difference between them. So a partition in a table is actually a directory. In this case, the table is still an entirety. And since making partitions is just creating some new directories and updating the metadata, it is cheap and the partition number is not fixed. Namely, the partition number can be changed, and further partitions or even buckets can be created in the partition. However, things are totally different for buckets. We say that each bucket is a physical file. Namely, we indeed divide the big table into several small tables in a physical way. So it requires many resources, and thus the number of buckets needs to be specified when creating a table, and could not be modified again. Now, look at the right part of the graph. We can see two types of data: skewed data and normal data. What's the difference? If a Hive table has 1 million records, where the ratio of men to women could be 1 to 1 roughly, now we regard the data as normal data. But if the ratio is 10 to 1, or even 100 to 1, then we call it skewed data. Skewed data may lead to low analysis efficiency, unbalanced data distribution, or even a wrong analysis result, so we must pay attention to it carefully. In most cases, it is easy to make partitions, but partition may cause skewed data. But bucket is using hash algorithms, and thus the data size of each bucket is roughly the same, which indicates that bucket is less likely to be skewed. That is all for this chapter. In this chapter, we mainly introduce Hive as a data warehouse based on the Hadoop ecosystem. Then we mentioned the application scenarios of it, some comparison between Hive and traditional data warehouses, advantages and architecture of it, and data storage model of it. Hope you guys enjoy all the contents in this chapter, and see you in the next chapter.